Hello, my name is Andy Atherton, an automation specialist at Kendall Electric. Welcome to the second video on the SensoPart Visor BLOB Detector. In the first video, we explored BLOB segmentation, the process of setting a threshold to separate an object from the background. In this video, we will explore the Features tab, which sets criteria for defining a blob and extracting information about it. This is known as blob analysis. This is what makes the Visor BLOB detector so powerful. By default, on the Features tab, two features are enabled: number and area. The first specifies how many blobs, if any, that you want to detect. As with many other detector parameters, there is the option to invert the settings, automatically detect the limits, and additionally enable or disable the feature. The second is considered in image processing to be a moment. Moments are values that are calculated according to specific equations that consider the intensity and location of each pixel in the segmented object. Area is the zeroth moment and is simply the sum of all pixels in the segmented object. Upper and lower limits can be set to exclude found blobs that don't meet a specific size criterion. Tighter limits mean that objects must be more consistently sized to be considered valid. This is not always appropriate for something that may vary in size, but may be useful in other cases. It is possible to add additional moments and information by selecting additional values from a list and setting limits to further specify which blob is found. Area, including holes, considers the entire area of the blob, including regions that would otherwise be considered background that are enclosed in the blob. As can be seen with this blob, it can make a significant difference. Contour calculates the distance around the perimeter of the segmented object. Compactness calculates the eccentricity of the segmented object. A value of 1 indicates a perfect circle, and as the value increases, the object becomes more oblong and less regular. The center of gravity x and y calculate the centroid or geometric center of the segmented object. The limits specify where in the field of view the center of gravity of the blob can be located. Average brightness calculates the average intensity of the pixels in the blob. Now we come to bounding rectangles. The R1 rectangle is the rectangle that circumscribes the extents of the blob aligned to the image frame. As the blob rotates about its centroid, the rectangle changes aspect ratio. This feature has subvalues pose x, pose y, which are the center points of the rectangle, the height, and width. Width is always aligned to the x-axis of the image and height to the y-axis. The R2 rectangle again circumscribes the blob, but it is aligned to the blob frame. So the size of the rectangle remains about the same and rotates as the blob rotates. This has the same subvalues as the R1 rectangle, but also has two angle values. The width value is always the longer dimension of the rectangle, and the height is the shorter dimension. These correspond to moments, known as the major and minor axes of the blob, respectively. The angle 180 value gives the orientation of the major axis between -90 degrees and 90 degrees, with 0 degrees at the 3 o'clock position. Angle 360 gives the orientation of the major axis between -180 degrees and 180 degrees, with 0 being at the same location. To reduce ambiguity of the orientation, it is calculated to the point in the direction of the furthest perimeter point from the center of gravity of the blob. Circle fit adds some unique capabilities. It also has subvalues including pose x, pose y, which define the center of the circle, and radius, which provides the radius of the circle. Deviation in deviation out, and deviation mean will find deviations in the perimeter from the best fit perimeter of the circle. This can be handy when detecting defects in a round object that wouldn't necessarily affect the radius significantly. Finally, we have equivalent ellipse. This specifies an ellipse whose size and shape generally describes the blob. It also has subvalues similar to the R2 rectangle and follows the same conventions for pose X, pose Y, width, height, angle 180, and angle 360. It has two additional values, axial ratio and face up, down, based on area. The first is the normalized ratio of the major axis to the minor axis. The second can determine if an object is ventral or dorsal side up based on the area. It uses an axis created by the center of gravity and its orientation to determine which face is up. This works when the object is not symmetrical about its major or minor axis, or both. The ability to access all of this information about an object and set limits for those values makes this detector extremely powerful at detecting both regular and irregular shaped objects. Further, it enhances the capability of making decisions about them. Coupled with the result processing detector, inspections that other vision sensors wish they could perform are actually possible with Visor. Try the BLOB detector for detecting objects that may not be consistent in shape or size, or when you need detailed information about them. You'll be pleasantly surprised. Thanks for watching this video. For more information about SensoPart Visor, please contact your Kendall Electric account manager or vision specialist. Visit our website at kendallelectric.com to find the location nearest you. Stay connected to us by subscribing to our YouTube channel or following us on Facebook or LinkedIn. Thanks for taking the time to learn about the Visor BLOB detector, and we will see you again on a Kendall Quick Connection video.